I see a red light. I'm on the air. I hope. Hi, boys and girls. My name is Butch. My name is Terry David Silvercloud, like silver in a ring and a cloud in the sky. And I am completely European descent. No native blood whatsoever. I changed my name 20 years ago, and that's another long story. So I use all my names, Terry David Silvercloud, and these days I go by Butch. I'm 74 years old. I live alone. I have chronic pain issues. Very painful day today. So it's a cool, gray, and showery day here in Vancouver today in Vancouver. Gee, I said that twice. Did I give you the date? 9th of November 2018. So because I live alone and to beat the loneliness, I keep busy by working on my art. I'm a painter. And I make videos for something to do to try and educate some of you or entertain you, whatever. What do I care? You're watching. Made you look. So if you're here, you're either curious about what the heck is this all about, or you have an interest, I would assume, in physics and in particular either particle physics or thinking about reality at the very elemental level of reality, like, well, where did all this hell come from? I don't like Earth. I don't like the humans. I'm living in hell. I don't know how I got on this planet, and I'll be off soon, so good riddance to all of you. Deep trouble is coming. As a scientist, I can tell you, you're all in deep poop. And I'm trying to help save you all by passing on what I think. So this entire video will be my opinion, because just in case I croak any day, which I could at my age, I thought that who reads papers? People publish papers every day, and who knows who reads them, and science is almost by popular science these days. What's popular? Big Bang is so full of crap that the only reason that it's around is it's popular. Big Bang is so full of holes. Give it up. So today I'm going to tell you how I believe one can construct an entire universe with suns, planets, materials, with some really fundamental requirements. I'm going to burp. Using all our basic fundamental laws of physics, of which I know, and I know a lot of them. I'm pretty well educated, and I'm into physics, and using mathematical theories and ideas, everything I know that we already know, but constructing everything except life. I don't know how life, I have a theory about life, but that could be another video, and life can be entirely accidental, and that's where I talk about dimensional levels of reality, that being alive is, time is a bit of an illusion based on your size, and being alive is a kind of a dimensional reality which requires physical reality, which requires a whole lot of things. So I'm not going to go that route. I just want to talk about constructing the physical universe and not talking about life, where life comes from, how life begins. Nothing to do with that. We're at the really rock bottom level here, and I said Big Bang is just a silly idea because it doesn't explain what came before, and just a multitude of reasons. So you have to begin, in my world, with the assumption that eternity is a kind of a time illusion. It's not that it doesn't exist, but it doesn't really have any meaning other than infinity. So you have to realize that we live in a reality which has infinite possibilities, even if the time element is relative to our own lives. Time is a measure of change in how quickly things change is how we measure time, and on Earth we count the frequencies of a particular type of crystal vibrating, or another atomic clocks measure the rate of decay of a particular type of radioactive material. And we know for a fact now pretty much that the inertia of the atomic clocks affects how they keep time. I think it's delusional to think time speeds up and slows down. As soon as you make one of your constants a variable, nothing makes sense. So time does not speed up or slow down, just how you view time. And if the clocks, if the atomic clock's mechanical function of decay was altered by changes in its energy levels, which it should be, I mean, that's logical, then the clock, with reference to us, relatively has been making an error, and what's happened is it's moved into a different relativity field than the one in which we exist. I don't want to go down that path. I want to talk about creating a universe which you acknowledge is infinite in scope. There is no end anywhere. There is no up, there is no down, and you are where you are right now, and you're on a planet which is turning, which is holding you down on the floor. You're being pushed. Gravity is push, not pull. In my world, everything in this universe is going to obey the laws of flotation and the laws of buoyancy, exactly like your first and year physics courses, except that there is no up or down. So how do the bubbles know where to go when they're floating up or floating wherever? The bubbles know where to go because they're seeking the place of rest. And in the case of bubbles, that's not a really good example because gases expand. But if you had a sphere, a fixed sphere underwater, if you could arrange for it to seem to the water around it like it was exactly like the water around it, which is what submarines do. The submarine makes its volume and its weight match everything around it, and it just sits there. If you add if you take a bit of weight out of the submarine, it'll start to go towards the surface. So things are being pushed around in space. You got to start thinking of planets and solar systems and everything just being like an ocean which has no up nor down, and the up and down will be determined by your gravity, which will be the velocity of your motion. Your gravity will be determined by a combination of your inertia, which is determined by everything around your motion, and then what you yourself are doing. If you're just sitting there on the ground, your inertia will be all the forces trying to get you to somewhere of lower energy or rest, which will be on Earth. The only place you could do that would be dead center of Earth. Earth is making a helical wave through space, following the sun, South Pole forward, moving ever closer to the center of the galaxy. Sometime in the far future, Earth will be crushed out of existence by the pressures of having moved towards the center of the galaxy, and that's so far ahead. I don't think the humans are going to survive that long. The humans are going to survive, but not like it's going on now. So how do we get, I'm up to 9 minutes already. So how do we create a universe where it's infinite, where you have only one substance in an infinite reality? The substance would have to have the qualities of almost filling the universe, but not quite. That would be very helpful. If the substance had the desire to get away from itself and just fracture, fractally in any way it could possibly do, to become the smallest particle it could possibly be, it will just do that, and it will do it along lines of forces. A thing you should get into your head by observation is these lines of forces always seem to follow mathematical rules. And the reason for that is that mathematics is just a language describing numbers of things, and you can use it in a lot of ways. But in the world of mathematics, there's only a certain number of things that can happen mathematically. For instance, you can only have number one. No matter how many numbers there can only be one of them. And in the world of mathematics, it's important to have a number where there is no number. So 0 is a number. And our number system, the 1, 2, 3, 4, 5, 6, 7, 8, 9, originated in India. It moved by way of Islamic conquering into Africa, and it was discovered first by the Templars, who used it in their money notes. And then we know that the Masons in Europe were using numbers, because there are church beams with Indian, which is 1, 2, 3, 4, 5, Arabic, some people call them, but they're actually from India, Arabic numerals, so that when the beam was crafted and it was taken up to be put in place, there were no Roman numerals, there were numbers, which back in the, around the year 1000 or so, when there's a lot of, it was Stone Age, they're building cathedrals and castles, and, they got pretty good at building and not falling down. But the Masons, they were using those numbers, and we know for a fact the Knights Templar also used them. So I divert a lot because I'm ADHD and I have so much I'd want to tell you about. But to construct a universe, you should not start running down mystical, magical paths. You should observe things around you, and one of the things I noticed is that things like crystals, here's a crystal. I think the camera was refocusing there. So this is just a quartz crystal, but you notice how they just naturally form these really almost perfect shapes, which we call crystals. And even when mountains shrink, basalt, when protrusions of basalt, which is liquid rock, protrude, sometimes because of the nature of the way they cooled, they will form into these vertical, often 5-sided or 6-sided columns, and the columns are all that way, not just one, but all of them. So crystals and mathematically, for no reason at all that you can really think of, things happen. In the world of mathematics, a sphere, do I have my sphere handy? Here's a sphere, here's a sphere. You can see if you look really closely, because it's like a golf ball kind of thing. The problem in mathematics is a sphere, to be more perfectly spherical, must have an infinite number of vertices. If you're looking for the smallest particle, and it's a sphere, you haven't looked far enough. And this is no big new idea. The Greeks and a whole lot of people since have decided that mathematically the best shape is one with the least number of pointy parts, vertices, faces, the flat part, and edges, the lines. And that shape is a tetrahedron. Excuse me. So, camera freezes up here. I hope it works. I think I have enough memory. So if we get back to looking at our infinite universe, I mentioned to you that what would be good for it to be filled with one material that had one property, and that's that it wanted to repel everything around it. In other words, it just wanted to naturally move out and fill the space, but there was only a very small amount of empty space. We have to accept that the universe is infinite, but a box-shaped infinite universe is all very handy for measuring relatively from somewhere in space. But, it's just an infinite cube. And to make it truly infinite in terms of relativity, it would be easier to think of the infinity as a sphere, because by definition, a sphere has an infinite number of vertices, and in terms of time, who cares where it is out there? So even though we know the universe is infinite, from us, let's start thinking of it as a sphere, and that sphere at any given moment is full of something which is trying to get away from itself. Mathematically, we know that the way to be the smallest is to turn yourself into a tetrahedron. There's a tetrahedron. A tetrahedron is a four-sided equilateral pyramid, or any, if you want it to have flexible joints, then that's okay by me too. So if you want the joints to be flexible, it doesn't have to be exactly equal. It would be equilateral, but not necessarily. You get what I'm drifting at here? That would allow for it to be, if you thought of this as being some sort of fluid material, it's allowed to keep breaking down into tetrahedrons as small as it wants to, and it will, depending on the crushing pressures around it. And if you put a tetrahedron inside a sphere, you could calculate approximately how much space there was versus the largest tetrahedral shape there could be at any given moment in time versus your sphere in the same moment. Schrodinger's cat going on here. And that would allow you to think about how much extra space is there in infinity. A better way is to think about how you can tile tetrahedrons. And it turns out that no matter how tightly you tile tetrahedrons, you're always going to have a very, very, very small amount of space left over, which is, and I forgot what it is, it's just over about, it's between 3 and 6%, but I believe it's about 3%. So at any given moment, you cannot quite fill infinity. This may go against the idea that all space is full, but it will be at any given time, and here is the crunch. If you are so infinitely small, your measure of time might be in attoseconds, which is like, you would think a quadrillionth of a second was normal, because a quadrillionth of a second later, you were long gone. It's over. You were just swept along with the seas of space, and your whole situation. You might just suddenly, and the quantum field theorists will love this, you might suddenly come into existence as a standing wave of a larger tetrahedron than the tetrahedron of which you were a part. Now this should happen. So if you could pulverize naturally, because it's trying to get away from itself, to the smallest bits and pieces there could possibly be at some particular time. The Big Bang people would like this, but it just doesn't make sense in infinity. but maybe on a small Big Bang it would. If there were no actual objects bigger than the very, 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 very smallest, whatever it is, they would all, by mathematical reasoning, be tetrahedral. That's just the way it is. Math, I'm not making it up, it's mathematics. Go look it up yourself. So let's assume there's a point in eternity where this occurs, just for the sake of explaining all this. If you're going to build something, and I want to talk about this because I'll probably forget about it if I don't later. If you're going to build something like an arch out of stones, there's always a keystone. There may be a row of keystones, but there's always at least one keystone, and it allows the pressures above. Remember, I said gravity's push, not pull. The pressures above, all the gravitational forces above, then push against the rest of the arch, and it's being held in place by the physical wall on either side of it. So to build a reality, you have to have keystone particles. So where are they going to come from? Well, as all this stuff is moving away from each other, and always touching itself, but if one of them is this big and all the rest are so small, they're all I'm going to call this a tetrahedron for now. I just don't happen to have a tetrahedron around, and everything around it is just mushy tetrahedrons, and they're constantly shaping up with others. What was my point going to be there? See, now I lost myself. Oh. Jeez, I lost it. I saw my screen freeze there on me, and where were I? Oh no. We have to make particles. Oh, one of the things they can do is spin. And the tetrahedrons would be spinning just like a ball would be spinning. Now, if you are spinning in space, and if you're a physicist, you'll know this, you have a choice of, because there is no up or down, spinning to the right or spinning to the left. So if you were spinning to the right and you encountered an identical tetrahedron the same size as yourself that was spinning to the left, and you could line your bottom surfaces up, one tetrahedron to the other, you could spin together and use less energy. You're trying to come to rest, and even though you hate that other tetrahedron, it's actually your friend because it's spinning the other way. It's your opposite. It's your soulmate. It's spinning right, you're spinning left, or whichever way you want to go. And if you share the same point in space of spin, you start sharing a common pole. Now something is happening. When you were a tetrahedron spinning there, you didn't really have a north-south pole, really. But suddenly, if two tetrahedrons get together, they have poles which are almost at rest compared to their joined bases, which in mathematics would be called a dual tetrahedron. And all the energy is happening in that circular area around which you don't have to spin anywhere anymore, but you're going to be spinning because you're being carried around with everything else. You lose your need to spin, really, because one's trying to. This must make sense to some of you. Anyhow, now you are a more stable object, so that's all very handy to have two dual tetrahedrons sharing the same space. But now I want you to stretch your mind ahead and think, what if 8 of them got together? And 8 of them is an octahedron, and an octahedron is a shape which has 8 faces, and it looks like a four-sided, like an Egyptian-style pyramid. Somewhere in there there's an octahedron. Rather than being... Oh, let's get back to... So I gave you two basic shapes that could get together. A dual tetrahedron, and that's it. So this could be a kind of particle. And I haven't even come to electrons yet. What I'm trying to get at here is the illusion of particles amongst this stuff, which was all the same. It's just blobs, but just because of mathematics and forces, things just want to take shape, and the numbers will break down in accordance with the forces along the weakest points. Wherever it is, the weak points will break apart and the strong points will stay together. And this is happening so fast that we call it the speed of light. But I haven't got there yet. These particles are existing in a world where the speed of light is really, really fast for them, just like it's fast for us, but light speed depends on your size, and if you were living in a world where your clock measured in 1/1000th of a second, light only goes just a bit less than 1 foot in 1 nanosecond. And if you were living in the world of atoms, your light isn't going any further than you. You are already living close to light speed. Your reality is, from the point of view of somebody bigger than you, like us, you're already living at the speed of light. The particles in here compacted together are so close together, they are literally happening at the speed of light and forming what we think is a standing wave of matter only because of the way we view time. For the teensy particles here, look at this little ball. You can see it in my hand, and this crystal over here, they're about a foot apart. See, they're about a foot apart, but light in 1/1000th of a second can travel that distance. So light in the smaller objects has already been and gone. It's over with. It's already been there. I keep seeing my... Don't lose me here. I'm going to shut up soon because I want to get bigger. So the idea I'm trying to push along here is we have an elemental unit of goop that just wants to take whatever size shape will give it stability. And I was getting to an octahedron. I think octahedron. Oh, that's what I wanted. I was showing you the wrong thing there. So if you can take... where are you? If you can take a bunch of these things and form other shapes, they will tend to combine the simplest shapes they can and go together. And the next possible shape that could come up would be an octahedron. And I would like to suggest that some of these really small shapes are things like, I suggest that a neutrino has probably got the shape of an octahedron. And because octahedrons are such a stable sort of shape against the pressures around it, it appear not to have much energy. It would have some energy, but because it's smaller than the electron that I'm going to get to, it just doesn't much register. And the next one up that would be a really great particle is a really stable shape is a tetrahedron. So if you slice off the corners of a tetrahedron, like if you have an equilateral tetrahedron and you mark the middle points and you slice off all the corners, what will be left inside is an octahedron, if I remember right. I hope so. The point is, you can dice and slice things and you will find more and more platonic solids. But what you want to do to get a stable stuff is to have it have faces and edges, and that will make it more solidy. So if you could take larger shape tetrahedrons, and I've gone backwards here because the point I want to make is that no matter, if you take a tetrahedron, you can still slice and dice it down to nothingness, that there's going to be some point close to nothingness where you still have a tetrahedron. And if you take 20 tetrahedrons and you join them all at their apex, you will have an icosahedron. And in my reality, that is an electron. It is extremely stable. It can be broken apart, and it would have 20 tetrahedrons, which would be 20 gamma particles. The quantum field theorists will begin to see a path by which matter can seem to come in and out of reality, which they would like. Are you getting that? And I'm going to have to shut up soon because I'm already up to 31 minutes. So I'm trying to suggest to you, and I took way longer than I thought, and I don't think I said what I wanted to say, because I'm such a ditz sometimes. My reality consists of a universe with only one substance, and its quality is that it's trying to break into the smallest thing that it can, and it's going to follow mathematical rules of fracture based along lines of pressure. And with enough pressure, you can destroy pretty much anything. But no matter how small you make it, there will still be shapes. And the smallest shape will always be a tetrahedron. The largest shape of the universe is probably a tetrahedron from a mathematical point of view. And that these other little bits and pieces, the neutrinos and the gammas and the electrons, they can join together to form massive stable shapes, which I suggest take on the shape of tori. And tori are really handy because in the center, from the point of view of everything moving all at once, those are places of rests where electrons would just love to be. They don't have to actually join the torus, but that would be a place where there would be less energy and more rest. I can't keep going on and on. I should have tried to script this, and I think I've screwed up. But if you followed along, I think you got the idea of how you can create a universe using just really basic mathematical concepts and still have particles. And it's all because you can't tile any given size with tetrahedrons without having some space left over. You just can't. Mathematically, you can't. And that means everything is always trying to expand, and that constant desire to expand is the pressure which causes gravity. Gravity is push, not pull. Anything which has gained stability is trying to find a point in this massive flow of stuff, of rest. It's stable. It doesn't give a crap what the rest of you do. It's formed a stable structure, and the more vertices it has, the more stable it becomes. It will eventually become a sphere depending on how you view size. So I'm going up to 35 minutes. Butchie Poo is going to shut up. I'm not crazy. They had me tested. I'm just one of those. I was always a smart kid in the class, but I had other issues, and I just kept to myself and stayed away from the other kids. They were just all so immature. Lisa Simpson would understand. Oh well. Bye-bye, folks.